Hey Math Journey! Ready to crack a tough equation the smartest way possible? By the time we're done, you won't just have the solution, you'll walk away with a powerful math hack that could transform how you approach tricky equations. Imagine tackling this beast. What are the real solutions to the following equation? The cube root of 49 times x to the power of 4 times x squared plus 27 equals 5 times x squared plus 9. Looks intimidating, right? What if I told you there's a brilliant shortcut to solve this without even breaking a sweat? Before we tackle this together, take a moment to think about it. I'll give you a few seconds to ponder and come up with your solution. Okay, first instinct might be to cube both sides of this equation to eliminate the cube root, right? But hold on. If you do that, you'll end up with a 6th-degree equation. That's like jumping into quicksand, way harder than it needs to be. Instead, let's think smarter, not harder. We'll break it down using the power of mathematical inequalities. Trust me, this is where the magic happens. So, let's start by rewriting the left side of the equation in a more friendly way. The cube root of 49 times x to the power of 4 times x squared plus 27. We know that 49 times x to the power of 4 can be rewritten as 7 times x squared, multiplied by another 7 times x squared. So the left side becomes the cube root of the product of 3 terms. 7 times x squared, 7 times x squared, and x squared plus 27. Notice something? We now have 3 terms under the cube root. What if I call these terms a, b, and c? So, a equals 7 times x squared, b equals 7 times x squared, and c equals x squared plus 27. Now, when we add these terms together, a plus b plus c equals 7 times x squared plus 7 times x squared plus x squared plus 27, which simplifies to 15 times x squared plus 27. Next, we divide this sum by 3 to calculate the arithmetic mean. 15 times x squared plus 27, divided by 3, which equals 5 times x squared plus 9. Notice something? This result, 5 times x squared plus 9, is exactly what we see on the right side of the equation. Here's where it gets exciting. Do you remember the inequality for arithmetic and geometric means? It says for any set of non-negative numbers a1, a2, all the way to an, the average of the numbers is always greater than or equal to their geometric mean. Equality happens only when all the numbers are equal. Now, our cube root represents the geometric mean of a, b, and c, while the right side of the equation is their arithmetic mean. That's our key to solving this problem. For equality to hold, we must have a equals b equals c. So, let's set these terms equal. 7 times x squared equals 7 times x squared equals x squared plus 27. To find x, do start with 7 times x squared equals x squared plus 27. Subtract x squared from both sides, 6 times x squared equals 27. Divide by 6, x squared equals 9 divided by 2. Take the square root of both sides, x equals plus or minus the square root of 9 divided by 2. Simplify, x equals plus or minus 3 times the square root of 2, divided by 2. And there you have it, the two real solutions to our equation are, x equals 3 times the square root of 2 divided by 2, and x equals minus 3 times the square root of 2 divided by 2. Wasn't that satisfying? Instead of battling with a 6th-degree equation, we used the beauty of mathematical logic to find the answer quickly. If you enjoyed this challenge, don't forget to hit that like button and subscribe to Math Journey for more fun math adventures. Now that you've seen the answer, how did you do? Were you able to crack it? Let me know in the comments. And share this video with a friend who loves brain teasers to see if they can solve it without peeking at the solution.